Hi, my name is Brandon Graisley. I'm a high school math teacher, and we're going to work on common factoring today. This is the opposite of using the distributive property. We're going to take a complete expression and we're going to factor it into the pieces that would multiply together to give us that expression. So first, let's remember what factoring is just for numbers. If I have a number like 6, that's made up of two prime factors, 2 and 3. 2 times 3 multiplied together to give me 6. And you also have other non-prime factors. For example, I could write that as 1 times 2 times 3, things like that. But this is usually what we're most interested in. 6 is a kind of a small number. Let's look at a little bit bigger one. How about the number 24, which has 6 as a factor, actually. 24 we can break apart in a whole bunch of different ways. For example, we can write that as 2 times 12. But then 12 we could write as other things too. So this is 2 times, let's say that 12 is 2 times 6. And 6 we did up here already. This is 2 times 2 times 6 is 2 times 3. And I've gotten down now to that prime factorization, which is these are all prime numbers. And this is 24 broken apart into the things that multiply together to give me 24. And I could recombine these in different ways. Like if I put all the 2's together, that's 8 times 3 gives me 24. And so you'll get comfortable looking at a number like this. These are called composite numbers because they're made up of more than one prime number here. You'll get comfortable looking at these numbers and finding all these combinations, and you'll see a number like 60 and you'll realize, oh, I could use 30 or I could use 15 or a whole bunch of different ways to factor a number like that. But what we're interested in today is looking at expressions that are polynomials, that have some variables in them. So remember that we've already looked at the distributive property, which means we can take an expression like this and multiply the 2 times each of the parts inside of the brackets here. 2 times this whole expression, x plus 1, and we would say that's 2x plus 2. Today we're going to do the opposite. We're going to start with an expression like 2x plus 2. So let's do this one. And we're going to see that there is a common factor. There is a 2 in each part of the expression here. In each term, we see that there is a nice 2 there, and we want to take it out so that we have a simpler expression left over. So we see this as a common factor, common because it's in both. And I need to know what to write in here. Now I already know because we've done this one before, but how can I get from 2x plus 2 down to that x plus 1 that I'm looking for? Well, the distributive property says that if you multiply something by an expression, then you multiply it by each term of the expression, just like we've done here. We're doing the opposite operation, so maybe it makes sense to you that we're going to take each term and divide it by 2 in order to be able to take that out. So we multiplied by 2 to get this 2x and to get this 2. In order to remove that 2 and bring it out here, we're going to divide each term by 2. This is the distributive property in reverse. And so this 2 stays here. 2x divided by 2 is x, and 2 divided by 2 is 1. So that's how we can go from this version, the simplified version, to this factored version, by dividing each term by the thing that we take out. Okay, let's do another one that we don't know the answer to. How about we try 15x plus 10. So again, we look to see here and here, is there something in common between these two numbers, 15 and 10? Well, 15, let me just maybe write off to the side here. 15 I know is 3 times 5, and 10 is 2 times 5. And so I see that I have this common factor of 5. Both numbers are made up of a 5 and some other stuff. So if I, let me use my green here, or blue, if I divide 5 away from each term, what am I left with? So if I take 15x divided by 5, and I take 10 and divide it by 5. So I've written the 5 out in front, bracket, and inside of the brackets I have my original expression with each term divided by 5. So the 5 is here, here, and here. That's why it's there. Okay, 5 times 15x over 5 is 3x, which you'll see is what I get here. If I've taken the 5 out of my prime factorization of 15, I'm left with 3. And here, 10 divided by 5 is 2, which is what's left over here on my prime factorization of 10 if I were to remove this 5. So there's my expression factored. Now I've got a common factor of 5 removed from 15x plus 10, and that leaves me with 3x plus 2 inside here. Okay, let's do another one. How about we get some negatives in here? You know what, let's do a very similar expression. 15x minus 5. There's a negative sign there. Well, I can see already I'm going to have a 5 here and a 5 here, because I know 15 is 5 times 3. So let's divide that 5 out. 15x divided by 5 is 3x. Now 5 divided by 5 is 1, but this is a negative 5. So negative 5 divided by 5 is negative 1. So this here, I've got to watch that that negative sign stays with me when I factor this out. Okay, let's do a couple more. Let's try one where it's a larger polynomial. 6x squared plus 3x minus 9. Okay, so I've got a bunch of numbers here. What I'm looking for now is that each of these numbers, they all have to have a factor in common. Now I know that 6 is 2 times 3. 3 is, well, 3 is a prime number, so only 3 can divide into 3 nicely. So I've got 2 times 3 here, I've got 3 here, and 9 is 3 times 3. So I can see that I have a common factor of 3 in each of those numbers. So I'm going to divide 3 out of each of the terms, so the opposite of the distributive property. Let me write the whole thing out again here. 6x squared divided by 3 plus 3x divided by 3 minus 9 divided by 3. So once again, we write the 3 out front here. 6x squared divided by 3. 6 divided by 3 is 2, so that's 2x squared, plus 3x divided by 3. The 3's cancel, or 3 divided by 3 is 1. That leaves me with x. And here, 9 divided by 3 is 3, and that's a negative. So there's the common factor 3 divided out of my larger expression. I'm left with this simpler expression to work with. Okay, so that's a polynomial, quadratic in that case. Let's do another quadratic. This one's a little different though, because as I noticed, this, I'll just write it in here like that, that's got a coefficient of 1. There isn't a nice large number out in front here that has something in common with this 2. In fact, there's nothing but 1 that divides nicely into both of these numbers. But I do have something in common here, because there's a 1 out front here, but there's also a 1 right there. There's 1x here, and there are 2 x's here multiplied together. So I have a common factor of x. So let's write this out. What if I take x squared and divide by x, and I have 2x divided by x? So now, here I've got x squared divided by x. So x squared is x times x, and then I divide by x. One of those x's will cancel, and I'm left with just x. Here, 2x divided by x is 2. Okay, so now just to double check this, let's go through the distributive property again to multiply this back out, just as a self-check for ourselves. X times x is x squared. X times 2 is 2x. And you can see, looking at back up here, that's what we started with, x squared plus 2x. So we've done this right, and that's a way that you can check your work afterwards. Just expand it out and make sure you get the right thing. Okay, so that works pretty well. I want to just show you a couple more really fast things. If you try to factor something out, like let's say I have 12 minus 6x, and I see that there's a 6 for each of these, but maybe you don't notice that right away, that they're maybe you only say, oh, these are both even numbers, I can divide by 2. So I do that. 12 divided by 2 is 6. 6 divided by 2 is 3, and that's a negative. Right here, I factored this partially, but not completely, and I noticed that I've got some more stuff here. There's a 3 in common now between these values. That's okay. I'm going to write it like this. I'm going to factor out the 3 right now. I'm just going to write it out in front here like this. 2 times 3 times this stuff here, which is going to be 2 minus x. And I'm going to recombine these constant values, these just numbers out in front here, as 6 times 2 minus x. So when you're factoring, if you realize that you haven't factored sort of enough stuff at on the first time, you can factor out some more things and then just sort of recombine all of your values out front here afterwards. And sometimes you're going to get an expression that doesn't work out nicely, like let's say 3x squared minus 7. Here I have x's and here I don't have x's. Here I have a 3, which is a prime number, and a 7, which is a different prime number. There are no factors in common here, so this one has no common factors. And sometimes there's another way to deal with these things, but in this case there's nothing we can really do to work on this. There's nothing in common, and we're just kind of stuck as far as we know so far. Okay, so that is common factoring, looking for something that is in common with every term in an expression and then dividing it out of each term and writing it out in front and putting brackets around everything, just like this. Opposite of distributive property, and this is a really important skill as we're moving towards factoring trinomials. Thanks.